There you go, Danny.
Good morning, good afternoon, good evening. It's another episode of the Wednesday Technical Forum of LMTV, sponsored by Love My Tool. It's my great pleasure to have two of my best friends, at least over one I met, one I haven't seen in almost 10 years, one I have never met.
Face to face.
Face to face, yeah. But we see each other every week. In any case, we have Paul Offord, who is the special speaker today, and then we have Tim O'Neill, who is my co-host. But I would like to. I'm sure all of us have some heavy thoughts on our mind, and I'd like to turn it over to Tim to say a few things. Tim?
Well, first off, it's great to be here with my two friends. One, like you, Denny, I only met you a few times, and Paul, we've talked a million times over the air. So one thing I did want to say on a very serious note is I wanted to reach out to our friends in Western Europe that have been suffering through these terrorist attacks and the events following that. It's horrible. I saw many of them from law enforcement videos. It was awful. And all I can say is thank you for being our friends of the United States of America, and we wish you bon chance, just phenomenal success in working together with the world to rid ourselves of these horrible terrorists that have no care about harming innocents. And so let's just all stick together. We need to come together as a world. And hopefully at some point we'll be able to convince these people that we ain't bad at all. As a matter of fact, we want the whole world to be at peace. So thank you guys for being friends, but thank everybody out there for being, suffering through all this and becoming a world of, a world of peace, hopefully.
Yeah, I think, Tim, our website, Love My Tool, is, really catered to the network engineers, and in some way the network engineers are the first responders of some sort, that we are the people who runs towards danger and not away from it. And of course we have a much easier job. We don't have to deal with bullets and suicide vests, but I feel that I am blessed that we are protected here, or at least but in any case, with that, Paul, you have so you guys been working on a secret tool, right? Or is it not so secret?
I guess it's not so secret now. So yeah, one of the things that we decided a few months ago actually is we were thinking about producing a commercial tool to help us support our TribeLab effort, the TribeLab community effort. And we decided that one of the things I put to my colleagues was, we sit in an office and we work through network traces and we manage to match up traces and things like that. If we can do it in a human process way, why can't we encapsulate that in software? And so this is the first of just many ideas that we've got. We've got too many ideas really about things that we want to do to make it faster for us to analyze data and to help the community at large to analyze data much more quickly. And we're going to have a theme next year at Advanced 7, which is going to be faster, doing things faster. How do we get to answers more quickly? How do we analyze data more quickly? So that's really the thinking behind the tool. And it sort of also plays into a subject I touched on in SharkFest this year, where I did a session on packet matching. And so what I've done is I've stolen a few slides out of my SharkFest slide deck, and I'm just going to quickly show those, if I may, just to set the scene. So let's sort out my screen share.
And real quick, while you're doing that, Paul, Paul, some of our friends from Secure Active were actually in the hotel in downtown Paris. They were at that military event, and they do spend a lot of time helping the military keep safe. But they were right there in the building and heard the gunshots and everything.
Wow.
Wow. Okay. That's pretty scary.
Yes.
Yeah. Okay. Okay. So the tool is currently called TraceMatcher. I think that is the name we'll go with. Now we've started off with, and Denny will be very familiar with this concept of the minimum viable product. So what we're trying to do right now is produce something that has value and can actually do something useful and save people time, and that will be the starting point, and if you like, also a bit of a marketing sense check as to whether anybody actually wants something that can do this. So just some background. If you consider an end-to-end network, are you seeing my slides? Sorry, I should have checked.
Yes, yes.
You are. Okay. So if we consider an end-to-end network, we've got a client PC at one end of the network and maybe a farm of servers at the far end of the network. And we can install capture points across this end-to-end environment to capture packets in numerous places, and I show you 6 places here. And some of the issues that we face, if we want to match up the traces taken at capture point 0 with those at capture point 1, if we're routing through our local area network, which we probably will be when we're going across VLANs, then we've got MAC address changes and other changes. So that's relatively easy to deal with, but we also have to consider the fact that those 2 capture points may not be time synchronized. So we've got difference in timestamps, and actually matching them up on a packet-by-packet basis can be a challenge in itself. So that's a fairly straightforward challenge. The next one is if we go through a router, through a firewall, we can then get issues around network address translation. So the addresses that are seen in capture point 1 aren't the same as those that are seen in capture point 2. Across the internet, in this case, we've got things like IPsec, VPNs, and even if that's a wide area network, then we still have considerations around some changes in the packet layout and content, or the IP headers and the link layer headers. We have more network address translation at the data center. We've got an additional problem with load balancing, where we get things like SSL termination, or even if it's just doing load balancing, we have an issue with this thing called delayed binding, where the packets on at capture point 4 aren't even in the same order or in the same sequence in any way to those that you see at capture point 5. And I'm sure you don't remember, but I was giving a presentation on LMTV a few months ago on a mobile a mobile banking app, troubleshooting a problem with that, and I glossed over the matching of these packets, and Tony Fortunato picked me up on it and said, "That's great, you slickly covered over this, how do you do it?" Well, it's this sort of capability, the ability to deal with all these different translations and adjustments to packets, that we're trying to cope with in our TraceMatcher tool. So that gives you some idea. I'm going to skip over this because I think I've explained those. So then we come to what we've called our alpha test snapshot. So we've dealt with the first 2 issues, and the first 2 issues are matching up packets across the local area network and matching up packets across a WAN or across the internet. So those are the 2 areas that our first snapshot release deals with. And I'll go on to tell you more about the other areas that we're working on. But let me show you what we're able to do right now. So this is the tool. It's available at the moment to the TribeLab community. So if we go into the TribeLab site, and if you've joined the community, you'll be able to log in here. Let's just change this to my nom de plume. And now we've got this extra area here, TribeLab TraceMatcher. We come into here, we've got our usual layout with a support forum, and you'll see that we're already started to get questions about things that aren't quite working as they should in the TraceMatcher tool, which we're dealing with those bugs. We've got a user guide, which is a bit rough and ready, but it does give a pretty good description and instruction on how to use the tool. And we've got the install package, which is a Windows MSI. This is only available on Windows right now, although we are considering porting it to other platforms, but at the moment we're focusing on running this tool on Windows. And then we've got a demonstration video, and then this is quite useful so that you can try TraceMatcher without having to go away and capture at multiple points across a network. We've actually created a sample pack of trace data which is available for people to use and to play with. So that's available if you are interested in trying TraceMatcher and participating in our alpha testing. Then all you need to do is join the TribeLab community, and you get instant access to this. So the tool, the sort of thing you can do if some packets here, which are, this is actually the sample set that's on the TribeLab site. I'm going to select a couple of these and load those up. I'm just choosing them in this order because it lays them out in this Explorer window on the left in a sort of neat way. You can just select all four if you like. Anyway, here we see that we've got our traces visible within the TraceMatcher environment, and you can check all the detail relating to the traces. This is all extracted out of the trace header during the load process when I just clicked on the load button. Now what we have to do is we have to scan this information, and it creates a database that's then used to it extracts matching information out of the trace files. So we run a scan, and at this point we get the opportunity actually to filter down into certain areas. So if you were only particularly interested in 1 or 2 IP addresses or certain TCP or UDP port numbers, you can choose all that in this point here. But I'm going to just let that all default. I'm going to let this run in real time. It doesn't take too long, he says. Hopefully it won't take too long. But it's doing quite a lot of work here because it's reading through all the files and actually building a structure in memory that gives all the match points. So now we're able to, now we've got to this point here, we're able to actually match the traffic. So I press the match button, and I can simply drag and drop this information into these containers. So this represents the different capture points across the network. So first capture point, second capture point. I need a couple of others, so we'll grab 2 of those.
Paul, this would be nice to follow a stream if you had a stream going over multiple.
Yeah, sure. Yeah, you can do that. You can follow a stream right the way across your network.
Yeah, that'd be really cool, especially when you have multiple paths and you're trying to figure out who went where first.
Yep, absolutely. And the other thing you can do, even if you said had 20 files, 20 files at capture point 1, you can drop all 20 into the container, 15 into here, 30 into there, 40 into the next container. And the beauty is that it will match them, even though you may have time synchronization issues and all sorts of problems.
That's pretty good, because when you're looking for multiple paths going through multiple connections, it'd be really good to see, why is it being reset, and why, why is this session opening and then it's closing because it took another path. I mean, this is really nice. Sorry.
Yeah.
Sorry to interrupt you there. Sorry.
That's no problem. Okay, so now once we've got this stuff in the containers, we can simply run a match. So now what it's doing is it's matching up the packets across all of these 4 capture points and generating this result grid that you see in front of you now. Mm-hmm. Now, what you can then do is, so if we scroll down a bit, and if we take this line here, you can see that this was the trace file at capture point 1. This is the frame number in that capture. This is the timestamp in that capture. This is the data flow for the capture, you know, the addresses and port numbers. And then you can see the same across all of the other capture points, so across capture point 2, across capture point 3. There's a lot of information in here, so one of the things we were conscious of is you may not want all of this. And so just like with Wireshark, and we've used Wireshark as our sort of style guideline, you can do the same sorts of things in here as you can do in Wireshark. So I can hide columns. The columns I'm not interested in, I can hide them, and then, sorry, I'm hiding them that way, I can hide them more quickly that way. And I can later on display them again, so I can just focus on what really concerns me. So that's pretty neat, but if we look at this packet that I have highlighted here, you'll see that this is going in the direction from capture point 1 through to capture point 4. And what you notice is that it leaves capture point 1 at 8:36:20, but it arrives at capture point 2 about a second earlier, so it's gone back in time. And that's demonstrating the inaccuracies of the synchronization of our capture units in all these different places. But correcting that couldn't be simpler in TraceMatcher. You simply click that button and it immediately snaps it all to a reference clock. Wow. Now the reference clock we've set here is everything is referenced to capture point 1, but we could equally choose any of the other capture points as our reference. So for example, if we were capturing actually on a server, we might want everything referenced to the system clock time on that server, and so we could simply choose that as the reference point and it would re-reference everything to that point.
This would also be a great security tool, because like if someone fires off like Angry IP scanner, you know, you'll be able to see things that you've never been able to see before, how far they're penetrating into your network, what IP addresses are responding to attacks.
Yeah, sure. And we thought about the security aspects. Actually, it was one of the drivers behind this. One of the things that we thought, that we realized, was we're aware that sometimes an application or a web server support engineer will be aware that a service is being attacked, but there may be multiple entry points into their network, and so the question is, where's this traffic actually coming from? Now, if once we've cracked 2 further steps, which I'm going to tell you about, it should be possible to go to this tool and to identify the packets that interest you and then track them all the way back through your network, all the way back through address translation, load balancers, etc. So that's what we're aiming to do, so that it can be used for investigations into performance and stability problems, but it can also be used for investigations into security issues.
Yeah, because we're getting more and more deep attacks. And this really allows us to get in and say how far it's getting in my network. That's what they did at Target. They broke in. They got finally in by creating a false account, an administrator account. But then they started using the Angry IP scanner, and it just went out and started finding addresses that it could get to, what ports were open, what people responded to it, and then they started, you know, moving up the ladder. And they should have been able to see it, but since they weren't really watching it, they didn't get to see it.
Yeah. Okay. No, so it's this ability. You know, there's lots of people out there with these high capacity capture units. You know, NetSharks, InfiniStreams, Nixons, all these things. You know, and Gigastore, etc. And it's the ability to grab that data from multiple points across your network and make some sense of it. And that's what we're trying to achieve here.
We tried to do that at ClearSight, and we actually did a little bit of it, but nothing like this. This is awesome. This is awesome. Okay.
So we've also got the ability at this point to filter further. So I'm fairly certain there's some SSH traffic in here. No, there's not. Okay. Or do I mean port 22? It's probably port 22, isn't it? Yeah, port 22. Sorry. So I can filter down into that, just picking up the port 22 traffic. I can narrow this all further by saying, actually, I'm only interested in every row in this grid has a unique ID. So I can say I'm only interested in rows 15 through 32. I'll show you why you would want to do this in a second. So that now just narrows me down to 17 rows of data. So that's great, but then the great thing that we can then go on to do is we can then express, and so I then have the opportunity to then drag that into Excel and do even more processing. So you can see it's matched. This is matched across all 4 capture points, and indeed, if it misses a match point, then you get missing packets, as you can see here. We've got a bug. This adjusted time here, when the packets don't match, for some reason we're losing the adjusted time here. We know about this, so that's in hand. In fact, I believe the fix is available now for testing. So, but
that's software.
Yeah, that's software. That's right. So you can see here, for example, if you ignore the time issue here, you can see we've got packets here that were seen at capture point 1, but they're not seen in the other capture points. So somehow this traffic's got lost. And in fact, the reason is because actually this is a broadcast packet. That particular one is. So we've got that ability. So that's the matching. We also added in the ability to merge data. I'm not going to go into that because we're coming up to our time allocation, but it's a fairly simple thing. We can merge 2 traces, and at the moment you can't merge traces with a filter term, but we're planning on adding that ability when we come to the next release. And you can actually use this as a tool to filter and then export data. Some of the neat things you can do is you can, if you produce a merged file, it appears in this Explorer list on the left-hand side. And as with all of these, you can spin directly out from any of the files in the Explorer directly out into Wireshark. So it becomes like a bit of a workbench. You can use it to manage and manipulate your trace data, and then just immediately push it out into Wireshark and start analyzing the things that you're really interested in. The other thing we're going to do is we're going to add the ability to be able to right-click within this match grid, and whatever's showing in this match grid can then be shown in Wireshark. So that's an additional capability that we're planning to add. We got a couple of other tricks up our sleeve, but I'm not going to tell you about those for the moment because we haven't quite got them working properly yet. We've got some quite neat things coming up, and I'll share that with you when we've got something that we can demonstrate.
Oh, come on, Paul.
Well, all right. I'll give you a clue to it. Wouldn't it be neat if we could have 2 copies of Wireshark open, one for capture point 1 and one for capture point 2, and if we could then step down through this list and Wireshark repeatedly resynchronized to each row in here.
Oh,
so
sweet.
You would then know that packet 30 in capture point 1 matches 52 in capture point 2, and Wireshark would take you straight there.
Oh, wow.
So that's what we're working on.
That'll be sweet, man.
Yeah, we've got it working at some level. Unfortunately, if you do something strange to it, it then causes Wireshark to crash, which isn't so good. But that's something we're still working on. So I'll demo that when we've got something that's anywhere near usable. Okay, so just to finish off, I thought I'd just give you a glimpse into what's coming next. So this is an alpha cut. We just wanted to get it out there and get some feedback, and we're getting some great feedback from people who are using it. The thing we're working on before we release the eventual commercial copy is dealing with source and destination network address translation. So we want to be able to match across firewalls even when they're doing network address translation. And we already have the logic to do it, and we've proven it in principle. We just have to code it into the tool. So that's coming up in the actual release. We've got 10 releases mapped out at the moment. It gets quite advanced as we get further into it, but I can tell you about release 2, which is something that's an issue that faces many people when they're analyzing traces, and it's the issue that Tony Fortunato touched on, which is how do you match up trace entries across a load balancer, because actually things get resequenced quite significantly. And so we believe we've created the logic to do it, but we haven't actually proven it yet. But that's going to be coming out in the second release. So that's what we're focusing on there. And that release will probably also have the Wireshark synchronization mechanism that I just spoke of. So if we crack the issue with Wireshark synchronization, that will be in that release. Further information, a good thing if you want to get into this stuff and understand the challenges, then if you go to the retrospective section of SharkFest and you look for the presentation I did on packet matching, that will explain both the challenges and the theory behind how we're doing this. So it gives some insight into what it is that we are trying to encapsulate in software. Obviously, the TribeLab community, and of course you can contact me. So that's me done. If I can just stop.
That's pretty awesome, man. That really is nice.
Yeah, let me just see if I can switch off the screen sharing now. Oh, there we go.
There we go. You're back.
Yeah. Yeah, we had 2 or 3 different ideas for tools, and we decided to go with this one because it's quite small and well contained. The other 2 are quite ambitious. So this is a good tool to start with. We're not trying to produce an APM product or an NPMD product. We're not going to try and compete in that space. Obviously, we can't. We haven't got that sort of research capability or development capability. At the moment, we're doing this during bench time, so it's not going as fast as I want. These things never do, but it is progressing quite well, and we've stayed really focused on it. So it's coming along quite quickly, considering we don't have a full-time development team on it.
Well, software is always hard, especially when you're covering new ground.
Yeah, yeah.
So Paul, where do you think? So this is all done under TribeLab and not Event 7. Event 7 is kind of your commercial arm. Is really the professional service part, right, of your business.
Yeah.
So this is done under TribeLab, and
yeah.
I assume that the people are there's a lot of overlap, right, between.
Yeah, well, the people who are doing the development are benched consultants. So it just so happens that 2 of our problem analysts are application developers, and then obviously we have to create test data, and we have to test it in-house as well. So because the guys who I work with are doing this sort of trace analysis and trace matching day in, day out, they're great guys to test this.
Yeah. So the question that I just have to ask, being an entrepreneur, is where is the return on all these investment, whether it's in financial terms or in effort terms?
Okay, so
where do you see the business side? Where are you going with this?
Yeah. So with the TribeLab community, the concept was to promote the whole idea of evidence-based troubleshooting and by implication, that assists us in marketing and selling the services of Advanced 7, but that can only go so far. And we've put quite a lot of money into the development of TraceMatcher so far. Mm-hmm. And if we want to, and quite honestly, if I was in the community and I wanted to use a tool like TraceMatcher, I want to see it develop as quickly as possible. And to do that, we've got to have a revenue stream. And so TraceMatcher will be the first commercial product. Whereas we've produced things like Transum and we've given it away, TraceMatcher will be a licensed piece of software generating a revenue stream. And
at the moment it's free.
Well, the alpha version is free, but the final version will look, I think, will look a bit different to the version you see now. I mean, the version you see now is it's neat enough and it's professional enough, but it needs tidying up a bit, and it's not until you get to release 1 and release 2, that you'll have the full capability, and those are releases that we won't be giving away. So sure, you could download this alpha cut right now and you could use it to match traces. There are no limitations on it at the moment. It can match traces as big as you like and as many as you like, but there are changes coming down the road that will mean that you'll probably want to switch to the commercial version.
Yeah. So this is really exciting development, and we get to see it at the ground floor, so to speak. Yeah. I hope so, and I guess our main theory is that people look at it and say, so what? What do I want this for? And that's why we want to make sure that we produce something that's useful, but where we can judge that there's a level of interest in it. Because I don't want us to spend a lot of money developing something that nobody actually wants.
Well, it takes a while because you got to teach people about the value of it, because people every day people are hitting engineers from 900 angles, and they're struggling just to use Wireshark as a basic forensics tool and visualization tool, and they don't understand the fundamentals. They don't understand that span will slow down your access, that it'll be variable if you're looking at real-time protocols. If you're trying to do like what you're doing and looking all through span and RSpan, you got problems. They just have to grow into it and learn it. But once they understand, they can put together a flow and actually see how it's going through the network, where the bottlenecks are, where the tool, where hack tools are at, scanners and things like that. I mean, this thing is awesome. I mean, this is really a powerful product. Yeah, I mean, just to be upfront, there are other TraceMatcher tools around. For a start, there is a sort of trace, a fundamental or sort of rudimentary trace matching capability in Riverbed's packet analyzer product. Yeah. Mm-hmm. And I know that many of the other providers also have trace matching. I think the area where this will sort of differentiate itself from those is once we start to move into those later releases. I mean, even the time adjustment thing is pretty neat right now. Some of the other things we're doing with the integration with Wireshark and with the ability to cope with NAT and what's called delayed binding, that's going to really differentiate it from the other products. And I don't see it as a replacement for the other products. It's just another tool in the armory, Well, I mean, and networks are getting more complex. The communication we carry on in the network is getting more complex. This gives you deeper visibility. I mean, it's just...
And it's about speed. It really is about speed, because manually we are performing this process right now, but it takes time and it takes practice, and this is just going to speed up the process so much, much more by several factors in terms of matching up those traces and getting full value out of your InfiniStream estate and your NetShark estate and your GigaStore estate. It's they're capturing all this data. Well, let's use the stuff and get some real value out of it. And this is a tool that helps you leverage the value out of those products.
Well, I think that we look forward to seeing more of that, and but I think for today it's a good introduction.
Good. Thank you. Thanks for the opportunity.
Thank you, Paul. Thank you, Tim. I'm going to sign off, and we have a couple more shows before the end of the year. We have one next Wednesday on the 2nd with one of our sponsors, Extra Hop. And if I understand it right, we have another one on the 9th with another interesting company, right, Tim?
If we could handle it on that day, you didn't get back to me yet on that.
Yeah.
But yeah, that'd be great. It's
Okay.
The company's called, it's spelled UILA, but it's Hawaiian, and it's Huila, and it's kind of like lightning, and it's really for the VM. It's for visibility in the VM world, and it's very interesting. It's started by a mutual friend of ours, being off, and I think it's going to be a pretty interesting solution because as we become more virtual, less visibility. I don't know where my data's at. I don't know who has control of it. This will help with all those questions you have in the virtual domain.
Well, with that, I'm going to sign off and be safe and be awesome.
Everybody have a beautiful Thanksgiving and a safe one if you're in the United States.
Yeah.
If you're over in UK, just have a pint for me, will you?
All right. With that, thank you very much. Bye-bye.